In this talk, we present our paper on authenticating drivers using automotive batteries. This is a collaborative work with Dr. Yuanchao, Dr. Youngmoon Li, Dr. Dongyao Chen, and Dr. Kang Shin from University of Michigan. Let us start our story with keys or keyfobs, which are the dominating solutions for vehicle immobilization. In general, these keys or keyfobs work in two steps. The vehicle's authenticator first communicates wirelessly with the key for server authentication. And if successful, it will notify the vehicle's power control module to enable the cranking of engine. This way, we can see the key-based immobilizers rely heavily on cyber communications, which, however, incur significant vulnerabilities that could be exploited by thieves to steal the vehicle. Here we list 11 cyber incidents occurred with keys or keyfobs in 2019, involving both white and black hat attackers. These cyber vulnerabilities, together with the thus caused real-life incidents, drive us to design a physical immobilizer without using the vulnerable wireless communication nor the in-vehicle network, thus providing vehicles a physical isolation from common cyber attack vectors. Our design is driven by two key observations on automotive batteries. First, battery responds to a given load with unique voltage, which allows the drivers to define their authentication code in the form of customized e-system operations. This way, we can use the automotive battery as a sensor to validate the driver identity via behavior-based authentication. Second, the vehicle engine is not crankable without sufficient power, allowing the use of battery as controller to dis or enable vehicle driving by reducing or restoring the battery's maximum output power. Following these observations, we designed BAuth, a battery-based second-factor driver authentication system. BAuth is an add-on module installed between vehicles and their batteries, which uses the battery to validate driver's identity and then dis or enable the cranking of vehicle's engine based on the validation results. BAuth needs to address three technical challenges. That is, when to activate the authentication service to reduce the power consumption, how to extract and match the voltage fingerprint to ensure authentication accuracy, and how to control battery power to achieve reliable vehicle immobilization. We have prototyped and evaluated BAuth on 6 vehicles, demonstrating its promising performance as a novel driver authentication solution. Our user study with 174 car owners also corroborate the value of BAuth. Instead of going to the technical details of BAuth, let me show you a demo video with its installation and operation on the 2008 Honda Fit. I will silence myself during this demo video to avoid interference. Please send email to liang.he@ucdenver.edu for any questions. Thank you.